Hey everyone, this is Florida Engineering. Today I am joined with Kash. He is one of our civil engineers here at Florida Engineering. Kash, tell us a little bit about yourself.
I am originally from India. I did my bachelor's in civil engineering back there. I did my master's in civil engineering from Clemson University and graduated in 2018 and have been working here since 5.5 years now.
Very nice. What inspired you to get into structural engineering?
Well, growing up, math and physics were kind of my favorite subjects in school, so I knew whatever I wanted to pursue as a career has to be like a natural derivative of that. So I was drawn towards the more physical branches of engineering like civil, mechanical, and I come from, like, my family has a construction business, so I grew up watching a lot of construction in the civil field. So I think that kind of pushed me towards taking civil engineering. And even under civil engineering, there's a bunch of different specializations that you can take, but for the reasons that I just mentioned, structural engineering was felt like the most natural course to me.
Nice, very nice. And you're licensed in 8 states, correct?
I am, yes.
Okay, 8 states. How do you navigate all the different regulations and the environmental challenges? Because, for example, like Florida, we have different statutes, we have different regulations compared to, say, Texas, where you're also licensed, right? How do you navigate all that?
The 8 states that we're licensed in, the good thing is there's some commonalities between them. Like, they all have their own building code, but they're all the state building codes are derived from the international building code. So it's not a world of difference. They have most of their sections align, if not completely agree with each other. Most states also require you to test for certain general conditions, like getting a little technical here, but the first thing that any structure you need to test for is dead loads and live loads, which is just the weight of the building and the weight of the occupants. But Florida, for instance, the wind governs the design, and because we have wind speeds going up to 200 miles per hour. And as you go further north, say North Carolina or Colorado, you have snow, which then takes over. South Carolina has earthquakes. So it's just a matter of checking. You have to check all these loads and not just the worst one, but take the worst combination of all these. It helps that if you're familiar with the International Building Code, and then it becomes easy to refer to the slight variations that each of these states brings to you.
So essentially you're over-engineering each thing that you apply yourself to, just because you want to make sure all the bases are covered.
The engineering term for it is factor of safety. Check everything, and then you take the worst possible combination of all the loads, because I like to say that, like, we don't design buildings for sunny days in the spring. We design them for hurricanes and earthquakes and tornadoes and floods, and we want these structures to remain standing in the most adverse conditions.
Yeah, no, absolutely. So you've been closely associated with developing, design methodologies that have now been adopted by Florida Engineering, especially with the transition to finite element design.
That is correct.
What exactly is that, and can you explain the transition?
That is a great question. So finite element design, in simple terms, it's a numerical method in which big structure is divided into smaller segments. Each segment is individually analyzed, and then the results of those analyses are put together to give you the composite effect. So, for example, before finite element analysis, what used to happen is that if you're designing, say, a small building, you check all the beams using the code mandated formulae. Those beams are in turn supported by columns. Those columns are in turn supported by footers. So the load on each is transferred to the other, and you have to check each element successively. Then there are certain cases in which you have to check certain members, such as beams and columns in combinations. For example, when you have wind acting on a structure, it acts on the entire thing at the same time.
Right.
Finite element enables you to do a complete analysis of the structure and not in segments, because the way finite element analysis is done these days is by using software, and there's so many, but what it enables you to do is model the entire structure in 3 dimensions and apply the loads that are applicable according to whatever state it is in, what the code mandates, and then it tests the entire structure as a whole, basically checking the effect that every element has on every other element. It can be a very complicated process if it's done by hand, which is why I mentioned that we use software for this, because it's just faster that way. It is so much more accurate. It really closely mimics the real life condition that the structure can be in, and that I believe has enabled us to become twice as fast, take on more projects, and overall increase our accuracy.
Yeah, I've noticed. I mean, we're pumping out almost 1,000 projects a week, and software like that, I'm sure, heavily contributes to that.
Absolutely, in large part.
And is this something, I know a little bit off of the question, is this something that's completely scalable? Is it something that, say we're handling 1,500 projects a week? This software that you've helped implement into Florida Engineering is capable of that.
It is. So when I started working here, it was we had one license of the project, and it was just me doing this. But as we hired more engineers, now we have, if I'm not wrong, we have a team of at least 15 master's engineers. Yeah. We have as many licenses, and everyone is capable of doing that. So basically, that is something we look for in our candidates, and that has enabled us to exponentially increase our growth.
So not only is Florida Engineering handling a large workload, but we've also the engineering team itself has contributed to development and improvement of various structural systems that are noted as innovative contributions to the aluminum industry. Could you kind of just give me a little insight on one of those?
Absolutely. So I know of some of the innovations that you're talking about, and where aluminum structures are concerned, what drives innovation is either economy. They want contractors want to find material that's cheaper or more economical, affordable. Or the innovation is driven by aesthetics. In Florida, it is not uncommon for your screen enclosure to be next to a lake or an open field or facing the woods, and you want an open view. So how this was conventionally achieved is that you one wall of your screen structure was completely supported by a beam, and that enabled you to leave
panoramic.
That enabled you to make it panoramic. You didn't need columns. Now that had limitations because the beams that are normally used by the aluminum industry, they're called self-mating beams. They only go as high as a 2x10. It's a 2-inch by a 10-inch deep beam. And so the natural way of thinking is you build a bigger beam, it can span a longer distance. But this is where the economy part of it comes in. Bigger beams also cost more. So a really interesting innovative point was realizing that a beam doesn't need to be strong throughout. It needs to be strong at the ends where it's connected to the columns, and it needs to be strong at the center where it experiences the most bending. So by reinforcing these parts, by reinforcing the ends of it and the centers of it, we've been able to achieve twice as long spans as any conventional beam by using a more affordable material.
So affordability, it holds up really well during heavy wind loads.
Oh, absolutely.
And all together, it is very aesthetically pleasing. Mm-hmm. So that's screen enclosures. Another thing that I'm very excited to talk about is barndominiums. Mm-hmm. So barndominiums are on the skyrocketing. People love the ability to have all of their toys in the same place that they're living, mm-hmm. and the open concept floor plan allows them to be very creative on what they're designing inside. Sure. As barndominiums, though, are gaining popularity because of the versatility and efficiency, what are some key considerations designing a barndominium, especially here in Florida? Is it common here in Florida?
It is becoming more and more common, and especially in the last couple of years, we have seen a tremendous surge in the number of barndominiums that are being built. A lot of development in the technology that goes into it, and like you said, it's an exciting concept. It is just as exciting for civil engineers such as myself, because it is always it gives us so much flexibility working with metal as opposed to working with concrete and masonry, because concrete and masonry come with a lot of limitations. They're not as workable, they're not as malleable as tube, steel, or metal. So barndominiums give us a lot of freedom in designing. They offer the contractor so much more options. They can create different layouts, and it is easier to create a cathedral type of a roof, because instead of having flat rafters, you can do ladder trusses. But like I said, barndominiums essentially are metal buildings that have been converted into dwellings or other uses. So that comes with its own challenges. So for example, because it has been converted into a livable space, it needs to meet the same insulation requirements as a regular conventional home would. And what I mean by insulation is protection against the elements, heat, etc. So in addition to the metal shell that we engineer, we have a department which specializes in the interior build out of a barndominium, as well as the calculation of how much insulation is required around it per the code mandates.
So energy efficiency, mechanical, electrical, plumbing,
foundation, and the framing shell of the building is everything. We have divisions dedicated to those areas.
So complete one-stop shop when it comes to barndominiums.
Absolutely, yeah.
And a screen enclosure if you wanted to add one to it.
Yes.
Have you ever had a project like that?
A screen enclosure with a barndominium?
Yeah.
Yes. We have seen a few, not a lot, but. Like I said, I completely expect the trend of barndominiums to only increase, and it won't be surprising that more and more of them will have screen structures attached to them.
Yeah, absolutely. I always dreamed about having one of them, just because I was always huge into the automotive world, or even being able to work on a boat. And if it's stored right next to where I can go ahead, wake up, have a cup of coffee, walk downstairs, and there it is.
Yeah.
Sounds nice.
I can see the appeal, and that is directly reflected in how many people are more and more people going towards that option.
Absolutely. So you've already talked about it. You've developed algorithms, methodologies for streamlining, drafting, and structural design processes. Can you share an example of how automation has significantly impacted project efficiency or outcomes?
Certainly. I've always prescribed to the belief that any engineering process that needs to be repeated more than twice should be automated. It's there's a lot of components that go into a single engineering project, so it makes logical sense to me that the more repetitive tasks that do not merit the time that they take should be automated. And as such, we try to automate all parts of the process that are common, so that an engineer who's working on the project can concentrate on the details and the analysis and making sure that all the connections and the members are fine. Just as an example, on the company website, we have a composite panel calculator.
Yeah.
So what that does is, a lot of composite panel manufacturers around the country, they have product approvals that tells you that allows you to select a panel depending on how much load is being experienced by the panel. But the real hard task is calculating the load that goes on a panel, because as I mentioned earlier, it's not just about calculating the load, it's about taking the right combination of it.
Right.
So what our calculator does is takes just a few pieces of input from the contractor or whoever is using that calculator, such as the wind speed, what height the panel is going to be installed at, and how much you need it to span, and then it automatically selects a panel for them and tells them which panel is ideal for their use.
Excellent. And that's on our website, the calculator and all of the abilities to select the different panels.
Yes.
Is that something that we're consistently updating, or is it a third-party update?
It is completely built in-house. We have created the calculator, and like we update it with every code cycle. So it is updated to the latest 8th edition of the Florida building. We want the contractors who come in with their projects to have a good idea of the panel that they're using, and also and on the other side of that is we don't want them to have to pay for a more expensive panel if a smaller one will suffice for their purposes.
So over the next decade, I mean, looking at Florida and the growth of Florida as well as throughout the rest of the country, especially with the additions of barndominiums on the rise, how do you see over the course of the decade things transforming when it comes to your role, essentially?
Mm-hmm. So, like I said, automation is going to play a big role. We already have some tools that we have developed in-house that automate part of the drafting process for us. We have the capability to draw metal buildings, screen structures with just entering a few pieces of input. I think this trend is only going to continue. We will soon have other tools that will allow us to draft and design even the most complex of structures, and vice versa. What I mean by that is soon we will have tools that will allow us to directly import all the information from a 2D CAD drawing into a 3D analysis model, where an engineer will be able to analyze it for the applicable loads. Instead of like spending the time to build that 3D model manually, they will be able to import all the data, including what is the beam size, what is the column size, what material is being used for the walls, all that, and that is why engineers today must understand that like it is very important to keep up to date with these changes, and like being open to the idea of automation and like understanding the interface and the internet between these programs.
Well, a lot's changed over the past 5 years. As you said, it used to be manual. Now the software is coming about that people are using. But, you know, when it comes to an aspiring child, right, it's obviously ingrained in you because of how you grew up to become a civil engineer. When it comes to the younger generation that wants to pursue getting into engineering, do you have any tips for the next upcoming engineers? Resources that they should be pushing towards, maybe a recommended school you'd like to see people go to?
Well, Clemson, go Tigers. Yeah, I think there is a few basics that like engineers can think about when they're thinking of going into the industry of structural engineering. If I'm to be very specific, I think every structural engineer should have a good base of structural loads and systems. They should understand the mechanics that go into any kind of structure, and the ASC 7. The ASC 7 is a book that it's like probably the most important textbook that I've had in my life. And it tells you how to calculate any load on any structure all over the country. It gives you versatility of design. You are not limited by only a certain region if you understand how to read and understand this book. And another thing that I would recommend is just staying up to date with the building codes, because the building codes sometimes have certain provisions that supersede regular rational engineering formulae, and at the end of the day, the building code is what we need to abide by. Lastly, I would say that many people seem, and I used to be in that number, many people seem to think that if you didn't take the right courses in school and then you start working, you made a mistake because now you don't have the knowledge that you could have had. But what I've come to realize is like engineering is a lifetime learning process. You learn on the job, and I would say most of what I know today I've learned on the job. And continuing education goes a long way. Interacting with our other people, having the right mentors, that kind of a thing.
Well, you've spent a lot of time here developing, new products and processes to help advance yourself and the company across the board. How do you stay ahead of the curve with all the new technology that's coming around? What do you have a certain networking group where people are talking about the newest software that's coming out? What's that look like?
Well, the simple thing, I do have a very good network of people, and I try to keep this network. Now we have 5 Ps right here in the company, and we try to learn from each other's knowledge and grow that way. Yeah. But additionally, I try to remember that like every 3 years the building code changes, and every 6 years we learn a whole different way of doing calculations than we do. And like the way to avoid obsolescence is to be well informed of these changes, and being open of these changes. For example, the Florida building code that just went into effect in January, it was out on the internet 6 months ago, and we at the company have spent the last 6 months studying it, updating all our calculators and all our tools to abide and conform to it, and just informing our customers of what changes are coming. And that kind of gives us an edge. That kind of gives us something that like takes us ahead of the curve, because we're not surprised by the changes when they're instituted, because we've had 6 months or more to prepare for it.
Well, Kash, it's definitely been a pleasure talking to you. Thank you so much for taking time out of your busy day. I know it's the end of the week, but thank you for sitting down and just giving me all this insight. I learned a lot out of this conversation as well. I'm still learning everything there is on the engineering side. But thank you so much for sitting down.
Yeah, absolutely. It's been a pleasure.
Thank you so much.